Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's webinar, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we will try to get to as many questions as we can during the question and answer period near the end of today's webinar. Okay, with that, we will kick off today's webinar, which is Security in CI/CD Pipelines, Tips for DevSecOps Engineers. Our speaker today is Stepan Ilyin, who is the co-founder and chief product officer at Wallarm. Stepan, how are you today? Thanks for joining me.
I'm good. How are you?
I'm doing great, thanks. I am the disembodied voice who's going to take herself out of the picture, put myself on mute, and let you get right into it.
Okay, sounds good. Thanks, everyone. Thanks for joining. Let me show my screen. So I hope everybody's seeing it. Okay, so today we will be talking about the security in CI/CD pipelines. And let me start from introducing myself. As Charlene said, I'm co-founder and chief product officer at Wallarm. I'm based in San Francisco, so if you want to say hi, swing by our office. What the company is doing is several products for application security and API security. So basically helping Fortune 500 companies and web scale companies to protect their cloud native applications and APIs from one hand, and from other hand to automate their security testing in CI/CD pipelines. So we know a lot of stuff about like CI, we know a lot of stuff how to make security part of it, and I'm willing to share some of the things that we knew from our experience. It's not a vendor talk by any means. Don't be afraid of it. So what I want to share with you today is mostly different kind of practical things that you can take away right after the webinar. Go and try out with your dev team, with your ops team, with the security team, like to have a lunch and maybe discuss what you can apply right away. This is the goal. Let me know, by the way, if anything of it works. The agenda is simple. So first we will go through the different kind of approaches to automate security testing from the CI/CD perspective for sure, because automated security, manual application security testing and automated security testing is very different. So we're talking about the CI/CD focus. I will recommend you a set of the DevOps friendly tools that you can take and use. In many cases, it's a mix of the open source tools and commercial tools. So you can choose whatever works better for you. And also I will share some best practices of how to implement them, how to put into your CI/CD pipelines. Sometimes it's obvious, sometimes it's not, and we just know a lot of things when people are making mistakes, and will recommend you and guide you to the right directions. And the last thing, maybe I will talk about the workflows, because it's all about the processes, right? And the workflows. So when it's possible, I will share some insights of how we can use the tools and how to get the best outcome of using them. Let me switch the slide. I don't want to talk a lot about the DevOps and how everything is evolving. So it's a kind of I bet you know a lot about that. But there's some of the things I want to highlight. The first one is we don't have boxes anymore. We don't have hardware boxes anymore. And what we see in a lot of companies is that they are moving from boxes, but they are also moving to the new way to operate everything. It's all about the APIs. It's all about automation. It's all about the immutability and isolations right now. Yes, we all have legacy apps. We have a lot of legacy infrastructure, but what we see more and more is that there's a huge shift from boxes to something new. And as a consequence of it is like we need to change a lot of things in how we operate and how we communicate between the teams, and basically what kind of tools we need to apply. Our security was a responsibility of security or risk team before. Now, like it's hard to imagine that it can be only in security. So I mean, it's developers, it's security guys, it's operation guys, and like everybody's connected. And this is the only way how it can work together. Manual tasks. We don't do manual tasks anymore. I mean, it's hard, and wherever it's possible, we need to think about the automation. And like the goal is to make it fully automated infrastructure. It's not possible in many cases, I know, but the goal is to automate everything. The caveat here is that we need to know how to do some things manually before how to automate it, and this is probably one of the hardest part. It used to be a case when we can just patch and restart servers. Right now, we do a lot of things in a new fashion, like if we know that some of the instance is vulnerable, we just kill it. Then we spin up this instance one again from the updated image. And there's a lot of things like that that require new tools and that require new processes. What I want to talk more during this webinar today is more about automated security testing, like basically how to automate security testing as a part of your CI. And Agile and DevOps are like up pretty much everywhere right now. So it means that we have short timelines, we have frequent changes, we have automated pipeline. We try to implement or already implemented containers everywhere. We use a lot of open source, and we try to manage everything over the API. This brings a lot of challenges on the application security side testing as well. Application testing is usually slow, so it basically takes time to finish testing. Also, it was a kind of like blocker for a long time, and it's not longer a case. Like we need to make it a part of DevOps and developer lifecycle, which is challenging. Our application security testing has a huge problem, and the problem is called false positives. We need to deal with this. It's hard to achieve complete testing coverage always. So like speaking about the automated deployment, we want to be sure that all the code is tested and all the code is tested for security. Unfortunately, it's hard to get a complete testing coverage, and it's always about how to deal with risk and how to get the best coverage in a result of using a mix of different tools. There are some other things I will get deeper there as well. So there is a zoo of different security testing tools that you can use, and we will discuss all of them in more details. But there's basically static analysis tools when you analyze source codes. It's dynamic analysis tools when you send a bunch of requests to the application with a black box approach and try to find vulnerabilities there. There is interactive application security testing. There is a way how we can look for secrets in the source codes. You can look for open source license violation automatically. And basically, there is a lot of things that you can use. And the goal for you is to understand what you're looking for. What kind of risk do you want to mitigate? What are the best tools for your CI pipeline and processes? And where to apply these tools in the best way, and how to get a mix of those that would be integrated with your workflows. So there's a small picture right now. I basically divided everything to continuous integration and continuous delivery and deployment. So there are some of the tools that you can use during the CI stage. For example, during the pre-commit, you can use some real-time static analysis tools right in the IDE. So basically, if you're a developer or if you work with developer, you can help them to deploy static analysis right into the IDE. And it works great, by the way, because if you see the issue and you can fix it right away, it's much more likely that you will be fixing it than in the case when you have a ticket after 5 days and you don't have time to return it, or you forgot completely what you wrote before. And there's some things that you can do during the commit. For instance, you can run the incremental static analysis and basically run the source code analysis of the new code there. There are parts that you can do during build stage. For instance, composite analysis, trying to identify any issues in the third-party dependencies. You can also run the full static analysis. This is the right place to do that. On the continuous delivery and deployment side, we basically have this test, deploy, and production phases. So during the test stage, you can basically use different kind of dynamic tools, interactive tools, fuzzing, hardering, and so forth. On the production, like you can basically order different kind of services that would run the continuously pen testing and red teaming and our bug bounties program. Let's discuss this in more details. Choosing the application security tools, you basically need to think about 4 things. The first one is integration. It's basically how easy is it to integrate these tools into CI/CD. The second one is accuracy. Like, what is the amount of the false positives? Can you use it? Like, would it be understandable to your developers? The third one is speed. Like, how fast is it? Because if you have CI pipelines, you don't want slow tools there, right? You don't want anything affect the pipeline execution. So you want the tools to be fast. And the fourth one is actionability. It's basically signal to noise ratio, clear guidance, what to be fixed, like easiness of pinpoint the problem in the source code. Let me start with the static testing. So for those who don't know what is static testing, it's basically the white box analysis. It means that you have a source code and you scan code to identify insecure patterns and potential vulnerabilities in there. This is probably one of the largest part of the application security market. There are a lot of tools to analyze source codes. There are some challenges there, and there is some best practices for sure. So let's start from the challenges. So the challenge number 1 is the false positives. You have the source code, and it means that you have a great coverage. You can go through all the source codes. You can find all the patterns of vulnerable software, of some misusage of some functions, of lack of input validation, and so forth. Unfortunately, there will be a lot of false positives. And what worse, you will have a lot of noise. We are talking with a lot of companies, and we see that many of those are tuning their static analysis tools a lot before they can use them, and before they can use them in their CI/CD pipelines. There were like some really strange cases when we come to the really big companies, really tech companies, and they're saying, hey, we have this commercial product A, but we're only using 10 rules out of it for our Ruby application, because otherwise we will have a lot of false positives. The second challenge is that it's hard to distinguish exploitable issues from the non-exploitable issues. Basically, you can find a lot of misusage of some function, but do we know from the source code if this function is executed at all? Probably we can, but like it's still very hard to pinpoint if this issue is really exploitable right now, if it's exposed to the attackers, and should we like tackle with it right now. Another challenge for the static analysis is that we don't have any runtime context. Basically, you have like you're analyzing the source codes or even the diff, like the new code, but it doesn't have any connection to services. It doesn't have connection to databases. There is no runtime there. So those are the challenges. Speaking about the deployment, you basically have several options. One of them I already mentioned. You can use plugin for IDE. Alternatively, you can make it a part of CI. And here you can run some diff, like diff scannings, analyzing something that was changed during the last commit, or you can run the full scan of the source code. And it's basically the best practice here is to use both of the options. So you can run you can conduct the scan of the code commit, but you can do the full scan, for instance, one a day or once a week. So both of the options are good. speaking about the pros and cons and this integration, accuracy, speed, and actionability thing, integration is fairly easy. So you basically have the source code in your pipeline, and you can easily analyze the full source code, or you can easily analyze the difference, some incremental changes to the source code. The accuracy I mentioned is a challenge because it has a lot of false positives and you will need to tune it. The speed is a nice thing because, like, if you run the analysis of the incremental changes, like, it will take probably minutes. It will be hours if you conduct the full analysis. Speaking about the actionability, it's actionable when because you basically have the exact line of code with the vulnerability. You can basically create a ticket for the developer by saying, hey, Mark, go to this file and please fix this vulnerability in this particular line of code. But you still need to, like, it's still a challenge how to identify what are the real issues. Like, this can be challenging. The tools landscape is pretty wide. So there is a lot of commercial tools from the companies like Checkmarx, Micro Focus, Synopsys, and a bunch of others. So you can find the tool for the tech stack that you are using. In most cases, those companies are now working with the integrations on like Jenkins plugins for CI pipelines, so it won't be an issue to deploy them. You don't necessarily need to start with the commercial tools. You can start with the open source tools as well. So for Ruby, so we have a lot of like Ruby code. You can use Brakeman and Kane. For the Python, you can use Bandit. And basically, I'm given a link here, which is called Awesome Static Analysis GitHub repository. So you can go there and find the open source tool for pretty much any language that you have. For the IDE plugin, it's not that easy. So unfortunately, most of the IDE plugins are commercial. Still, you can find something like just Google Visual Studio Code, security analysis, for instance, and you can find some plugins there, or like find the plugins for other IDE you're using. The next thing, dynamic testing. So we covered static analysis when we analyzing the source code. The next part is dynamic analysis. We call it DAST. So basically, SAST and DAST are the Gartner terms. You don't necessarily need to remember all those. Just dynamic analysis, you need to understand what it is. And by dynamic analysis, we mean that we send requests to the application or to the API and analyze the response of the application. So we basically use the library of the payloads like SQL injections, cross-site scripting, or we're using some fuzzing techniques to create these requests, to send them to the application and then analyze their response codes and like response content and the body. The good stuff here is that we can really find exploitable stuff. Like if you are sending the payload with SQL injection to the API and you see that it's like there is a SQL injection there, like it means it's really exploitable and you need to go and fix it right away. The good stuff, number two, is that you have the runtime context. I mean, you don't have the insights of the runtime, but the application is running. It has connections to the databases. If it's a microservices architecture, those microservices are working together, and you have like the full application that you're testing. Like, and it's really, really important. It's a huge lack for the static analysis that they don't have it. However, there are some challenges. So dynamic testing usually takes more time than static analysis. There's no surprise in that. You need to send requests, you need to analyze the responses, and it takes time. Most of the dynamic testing products can't scan APIs, unfortunately. So they were developed for a kind of old age of the applications when it was possible to crawl apps. It's not possible anymore, so it's a challenging for most of the products. Not to everyone, but for the most of it. And most of the DAST are really hard to integrate to CI/CD pipelines. And why is that? The reason for that is that most of the tools are developed for pen testers. So they are supposed to be run manually when there is the application security engineer or the pen tester who open the laptop, run the app, then run the checks and manually analyze it. And that's why it's really hard to make this app, like make this tool a part of CI pipeline. Another challenge is, like I already mentioned it, most of the tools are developed for old-fashioned apps, and it's really hard to scan APIs and as a result, single-page applications. So when you're choosing the dynamic tool for your requirement for your CI, you need to keep in mind these requirements. Does the tool support integration to CI? It basically means, does it has API that you can use to integrate to the CI? Does it have Jenkins plugins or Circular CI plugins to include into CI? The second thing, can it test APIs and single-page applications? Because if it cannot, like, it doesn't make sense to use it nowadays, probably, right? And the speed, like, it should be fast enough to be a part of CI pipeline. Speaking about the landscape, you have multiple options, but not too many. There is a great tool which is called OWASP Zap. It's open source tool. You can integrate it into CI with the CLI interface. It's basically console tool. It can be challenging to test APIs though. So if you have this old-fashioned apps, it's a good idea to use Zap, but it would be a challenge to test API. Another tool is Burp Enterprise. So a lot of pen testers like Burp tool. There is a special version of Burp, which is called Burp Enterprise. It has the integration, it has API, so you can integrate it with your CI. But there is also a challenge with the API testing. So unfortunately, what we see on the market is that people use Burp, but they are really like struggling with the testing APIs. The third tool is from the company I work for. It's called Wallarm FAST. FAST is framework for application security testing, and it basically conducts dynamic testing. It's also automate fuzzing. And we provide the integration with the APIs, we provide plugins, and we do our best to make API testing possible. So it's really powerful if you need to test APIs. Most of those tools, like dynamic testing, works in the same way. You basically have a set of the functional tests that create traffic that test different parts of the application. And you need to deploy proxy between the functional tests and your test application. You can, on this picture, you can, the proxy is fast. So basically you can include Burp, Zap, Fast, or other dynamic tools there and intercept the request. So it will help to build the baselines of the requests and basically understand what kind of application endpoints you need to test out. And then basically the dynamic tool will run those tests and report the results to the pipeline. This is how it works. Pros and cons of the dynamic testing. The integration really depends on your test automation. So basically, if you have all the tests in place, if you automate everything, it will be great because you can leverage your existing test coverage, take your existing functional tests, and create a lot of security coverage based on that. The accuracy is high, and it requires less configuration. If dynamic testing tool finds some SQL injection, probably it's SQL injection. The speed is a challenge, so it can take hours to finish the scanning. So there are some life hacks of how you can include dynamic testing into the CI. So what we see a lot is that people don't wait until the dynamic testing is finished. And meanwhile, they just run this dynamic testing in the parallel mode. So they don't stop the pipeline if there is anything created, anything identified like vulnerability or severe security issue, but they create the ticket. So in this case, the pipeline is not stopped and you're not introducing any slow element into this pipeline. But there are some cases when you actually can have the dynamic testing right in line and wait until the results are conducted. The actionability is a good thing because findings are usually really, really relevant. If you identify anything, just like fix it right away. And in many cases, you can make an assumption very easily. Is it exposed to the customers? Is it exposed to the attackers? Is it exploitable at all? And what kind of impact could be? However, you need to pinpoint the issue in the source code. So since dynamic testing doesn't have the access to the source code, you need to find the particular place in the source code to fix it. Let's go to the next one, category, and it's interactive application security testing. So it's basically a runtime code analysis that uses instrumentation. Simply said, it looks at the code when it's executed. The challenges here are that you're limited what is executed. So once again, as with the dynamic testing, there should be some test automation scripts that drive application behavior, so you can test different parts of the application. And in many cases, it works with only with the CI/CD, but from our perspective right now, it's a good thing, right? So it's not a big deal. What is not good is that you're really limited in the source programming language. So you need to find the solution that will support your programming language in your runtime environment. It's also a question like, where do you want to have this IAST agent? Like what we see a lot, people don't want any runtime agent running in production, so it's only can be used in the QA environment. However, some people are using it in production, and in this case, they can be analyzing like 1 to 10% of the traffic, just in case it can affect somehow the runtime. Most of the tools in this category are commercial. So there is a tool by Synopsys, it's called Seeker. There's a tool by Country Security. And unfortunately, you need to pay for all of those. So there are some attempts to create open source tools, but we don't see a lot of them on the market. The pros and cons here, the integration is fairly quick if you can include it in the source code. The accuracy is pretty high because the runtime gives you benefits. So the speed really depends on the test automation. It can be slow if you don't cover some particular parts of the app, and it can be quick if you really test some particular parts of the application with your existing testing. The next part I want to cover is the software composition analysis. So it reduces the risk, like the goal of it is to reduce the risk from third-party dependencies. So you can basically map dependency tree and find vulnerabilities in all open source dependencies, like direct dependencies and not direct dependencies. It primarily relies on the CVEs, the knowledge of the known vulnerabilities. And there are like a variety of tools on the market, like Sneak, GitHub, has their own security rules. There is SourceClear, and there is a bunch of other tools that you can use on the market. It can be very good, like adding a few lines of the code to your source code, like import something, and it means that you actually import 10,000 lines of code of somebody third-party code, and it's very important here to know that you are actually using the secure code. Secret detection is another thing. So developers hard code their secrets often. You will be surprised how often we see this kind of flows when somebody is leaving API keys or the AWS S3 keys or even SSH private keys in Git repositories. So you need to run the automated scans to find the secrets right in your code. The good thing that you have like a variety of tools for that. One of the tools that I usually recommend is the tool from Yelp. Like the name is very obvious. It's called Detect Secrets, which is very nice. There is also another tool which is called Git Secrets. It is developed by the AWS Labs. which is pretty similar. But I would recommend tool from Yelp because it can be used on the client side and it also can be used on the service side. On the client side, it can be integrated with a pre-commit hook by the developer. And on the server side, you can integrate it into CI pipeline, and it's also language agnostic. So you basically can use it with a Python, JavaScript, Java, PHP, and so forth. So thanks Yelp for developing this tool. Containers testing is another thing. So I know the containers still have a huge way for adoption. And we see a lot of companies are trying to use containers now. Developers are using containers now. It's not always the case when containers are used in production right now, but like we see this a lot. And if you're using the container-based infrastructure, you need to conduct the analysis of your containers images. So what these tools are doing is that they list all packages, files, software artifacts, and scan them. So you can find a lot of issues just by analysis, what inside your container image. And this is the hashes of the null vulnerabilities. It can be secrets, some lost credentials. It can be some outdated versions of the software. You can even analyze the static binaries with some of the tools. And you will be surprised how many tooling you have already. One of the most popular tools is Anchor Engine. This is the open source tools, but they have, like, the company also provides the commercial UI for that. It has Jenkins plugin. It can be managed with the REST API. It can be managed with CLI interface as well. And this is probably one of the best one. Another top tool is Claire from Coros team, or I don't know, it's probably better to say Red Hat team now. It's very good. Collector from Banyan is a good one. If you need to integrate Claire with the Docker registry, there's Claire. There are some capabilities for containers testing that are appearing in other products like Sneak. One of the recent ones, I did not use it by myself, but I saw it among some of the customers, is the Red Hat OpenSCAP. So you have a great variety. I would propose to start with the Anchor Engine first and Claire. Those are for sure are very good to start. So I'm pretty sure that you're thinking or implementing already infrastructure as a code concept. And here you should think the same way as with the source code of your application. So basically you have the configuration, you have all the Terraform templates, you have all the Docker images in one place. It's good to have, like, to store it in Git repository, and also to run the tests, all the necessary scans that you need. And only if the tests are passed, you create the golden image that you then use to orchestrate your infrastructure. Another thing is the license analysis. So it's probably a larger deal for the bigger companies, but you need to think when you have dozens of developers, this is a good time to start thinking about the automation of license compliance. So basically, you need to scan all the source codes for open source license violation. And there is a bunch of tools here. They are on the screenshot, like Black Duck and Sneak. This is a workflow. I just wanted to have all those tools, or at least some of the tools, and show you how it can look like in your pipeline. Let's go all those steps together. So developer commits code to the CI, and it triggers build in CI/CD. What you can do at this stage, you can write the composite analysis and basically analyzing all the third-party dependencies, indirect and direct. Then you can run SAST, and by SAST I mean here the incremental analysis. What was committed to the Git? You can run the quick analysis of that source code and quickly find any patterns of the vulnerabilities, which is pretty nice. Then you have some results. You can have some CV issues found. So you can you can stop the execution of pipeline here and notify your developers. I will talk a little bit later about how to prioritize the tickets, but it's important to prioritize them. So you need to know what are what vulnerabilities are severe and to stop the pipeline, and have some other vulnerabilities that are not that critical and let the pipeline to execute later. So if the vulnerability is not critical, you can create the alert, or you can create a ticket for developers, but not stop the pipeline. If there are no issues found, this is the best case, right? You can just deploy to non-production. Our non-production, in non-production, you have some test environment. You have the app running. So ideally, this is the full copy of the application, some test data. So here, your CI/CD server can invoke DAST and IAST analysis. So I spoke to that while discussing DAST and IAST. You can deploy proxy that will intercept the traffic of your functional tests and create the baselines, and then create a lot of checks that will be sent against your test application. And once again, you have those you have to make a decision if the findings of these tools are critical enough to stop the pipeline, or you're okay with them and you can fix them later. Aggregate vulnerabilities. This is the next step in this scheme and this process. This is very important, and I will tell more about that. You need to find a way how you can aggregate vulnerabilities and how you can work with them, because eventually you will have a lot of them. There will be a lot of duplicates. You need to find a way how you can get rid of the duplicates, find the most severe one, how to work with the developers to put them into their backlog, and how to take the remediation steps. So the number 7 here is the remediation. So you need to log ticket, you need to work with the developers to fix the vulnerability, and you need to orchestrate the testing again, so retests here. And only after that, you can release. I hope this scheme would be helpful for you. I mentioned the prioritization as an important thing, and it's really, really, really good, because it can sound easy, some of the things, and some of the things can seem easy wins, like the static analysis, of the incremental code changes, but you will face a lot of small issues and not the small issues pretty soon. So one of them is that you will have an overload of the backlog. You'll find a lot of issues, some critical, some are not, and all of them will be in the backlog. So we need to deal with that. You will have also duplicate tickets. And how do you know which of them duplicates? It's hard. Some of the companies are developing the tools and the strategies for themselves. I would propose to look at some of the tools. There is Defect Dodger, which is open source tool. I think it's a good start, and we have a lot of customers who are using Defect Dodger to correlate vulnerability and understand which of them are duplicates. There are some other tools which are commercials, like Altran, CodeDX, and Zero North. Feel free to take a look at them as well. Process-wise, what's important is to establish the red flags versus orange flags scenarios. You will have security issues, right? But now what? You need to know which of them are really severe, like SQL injection that was discovered by dynamic analysis. In this case of the red flag, you need to stop the pipeline, and you don't need to deploy anything. And in another situation, there is some potential issue from SAST. You're not exactly sure if it's exposed at all, or you're not sure if it's exploitable at all, and you need to consider this to be as an orange flag. So, and in this case, you need to continue the pipeline execution and pull the issue details into the backlog. So you don't need to stop anything. So it's very important to have these red flag scenarios and orange flag scenarios to put all the findings into the different buckets and have these different scenarios for the pipeline. because we all don't want to block the pipeline, right? So the whole idea of integrating security into the DevOps process is to make it a part of it and not to make it blockers. So you need to find the way how to make it organically. The last three things I wanted to mention here about the protection of the cloud workloads. So it used to be monolith kind of applications before, and that was easy. Now we have serverless workloads. Now we have instances of virtual machines. Now we have containers. And frankly, you need to have different strategies to protect those workflows. For instance, in serverless, you need to focus on the code and configuration. When you need to deal with the protection of instances and VMs, and I'm speaking about the infrastructure as a code right now, you really need to focus on that everything is made as a template and all your infrastructure is immutable. When we are talking about the containers, you need to focus on the code and you need to focus on the container hardening. So those things are very important. And there's a lot of things to talk a lot. I know it's a big topic. I hope I gave you overview of the tools, different kind of approaches, and the ways how you can integrate into CI/CD pipelines. But I bet you have some questions, so I'm here to answer those.
All right, great. So yes, we have about 15 minutes or so for questions. So if you have a question for Stepan, please go ahead and use your GoToWebinar control panel, and we'll dive right on into the questions we do have. First question, are the security tools same for CI/CD on cloud?
So in many cases, it's overlapping, right? So if you have CI/CD pipeline, in many cases you have cloud. But cloud is a very vague term. So you can have public clouds, hybrid clouds. I would say it's in most cases, if you're adopting cloud infrastructure, you're also adopting CI/CD procedures. So and the tools are more or less the same. But let me know if I'm answering the right question here.
Okay, all right, great. So the next question then, can I use OWASP ZAP for security testing on CI/CD pipeline?
You can do. ZAP is an awesome tool. Unfortunately, it wasn't developed initially to be a part of CI/CD integration, so it was mostly developed for the tool of a pen tester. However, a lot of people started using it, and the tool evolved in time, so you can use ZAP as a part of CI/CD for sure. So I'm a great fan of ZAP. There is a set of challenges there, though. So one of the most important one is the testing of the APIs. So if you need to test APIs, using ZAP could be challenging. If you have some more traditional applications, ZAP can be definitely a very good tool to start.
Okay, great. I think you may have actually answered my next question, which was how is OWASP ZAP different from Wallarm?
Yeah, so this is a good question. Like Wallarm Fast, this is the product which is similar to ZAP, but we have different, like several differences. One of them is the API. So we have a very rich API for automations, and for pretty much everything you can run the API call, and it just makes you much more flexible in terms of the integrations with your workflows and the tooling that you have. The next thing is the API testing. So we have a huge module to run, test, and fuzz the API methods. And we're using a lot of techniques to really profile the nested format. So if it's a JSON API with XML included, and there is some base64 field where another JSON included, we can identify all those application endpoints and fuzz them. And the third thing is speed. So for dynamic testing, the problem is the speed of the testing. So we made a lot of optimizations into our library of the payloads and fuzzing techniques, how to make it faster and be comfortable to use it in your CI pipelines.
Okay, great. Plenty of time for questions, guys. So if you do have one for Stepan, please go ahead and just put it in your GoToWebinar control panel. Next question here, do I need to install it on master or nodes in Jenkins CI/CD?
Is it a question about what? Can you repeat it, please?
Sure. Should I need, I think it's actually, do I need to install it on master or nodes in Jenkins CI/CD?
Yeah, I'm just, maybe it's related to the previous question. What was it about? Is it about fast as well?
It's unclear. I'm not sure if they're asking if it needs to be installed on
Let,
master or on, on the nodes, or I'm not quite sure. So Babu, if you wouldn't mind
I,
just maybe clarifying. Yeah.
yeah. Everything really depends. Like all the tooling that we mentioned in this webinar are the way how you will deploy them, the best way to deploy it really depends on your infrastructure. But this is the best part about the DevOps, right? You can you have a great flexibility and you have a lot of options all the time. And
Mm-hmm.
the question is how to find the best possible way to apply it. There are some tools that have some requirements. If it's static analysis tools, they need to have an access to the source code. If it's dynamic testing or interactive testing, those tools need to have test coverage. Otherwise, they will be limited in the identifying the places of the application or API that should be tested, and so forth. So it's just about some fundamental limitations and requirements of the tools and how to apply it in the best possible way.
Excellent. Okay. All right. Great. Next question. Do you have any packages running or any package running on GitHub? So straight away we could deploy and see how it works. So if you do, can you share and if you have any GitHub repo?
Definitely. So we have a GitHub repo. I will give you guys the link to that with the slides. And there is a couple of the things there, including some examples of how you can use the tooling in CI/CD pipeline for sure.
All right. Excellent. Excellent. So that'll be showing up on the screen shortly then. Okay, great. Again, if you guys have a question, please go ahead and submit it in the GoToWebinar control panel. And let's see. Next question, what are the two biggest mistakes then that people make when they're automating security?
Yeah, this is a good one. I would say the first one is trying to do everything at the very same time. So we saw this different times when we come to the customer and basically saying, hey, you can use static analysis, dynamic analysis, you can scan your containers and so forth. So and we see people are excited, they want to use everything, and they start to implement all those controls in place all together. And very soon they understand that it's really hard to deal with all those without establishing the process around it. So I would say that you need to start one by one. Like if you have containers in place, start with the analysis of your Docker containers. It's an easy win. You can set it in place right now, and it will also help you to set up a process, how you work with the developers if it's required, how you work with the security team if it's required, and after that you can switch to the static analysis or dynamic analysis, for instance. So don't do everything at the very same time. And the second thing, I would say this is something just related to the manual versus automated. It's really hard to automate anything if you did not try to do it manually. You know what I'm speaking. You need to run some of the things manually, understand the nature of the tool or approach, understand what kind of data you can get as an output, and try to use this data manually in your process. Once you get it, once you feel you're comfortable, once you understand what is the benefit and who in the company is getting benefit of it, automate it. But try it manual first.
All right, great. Okay, next question here. Let's see, how's Wallarm different from Twistlock? So contrast and compare.
Yeah, Twistlock is a great company. It's in a little bit different space. So it's really working in the space of the containers security, Kubernetes security. It's all about the protection of the infrastructure. Versus Wallarm is working on the products on protecting workloads like application and APIs and the microservices in real time against different kind of threats, and working on the automating of security testing of those assets. So we're not overlapping. It's just like different kind of solutions. Twistlock you need to use to protect your infrastructure, to harden your containers and Kubernetes deployments. Wallarm you need to harden your APIs, apps, and microservices.
Okay, excellent. Next question. Do you know of any reliable SAST tools for Elixir?
This is a good one. I doubt that there's anything on the market for sure for Elixir. I'm a great fan of Elixir, by the way, but it's really, I'm just speaking as a founder of the company, and if there is not enough market, it's really hard to justify the investment in supporting like additional language. So we're not working on the SAST, but if we are in the shoes of the companies working on the static analysis, we would think like how many companies out there are using Elixir right now. And even though we can love it, or another vendor can love it, it's hard to justify our support for Elixir or other brilliant languages and technologies if they doesn't have enough adoption, unfortunately. So I don't know the tool. This is the short answer. But let me know if you find one.
Okay, all right, great. Let's see, we've got a couple more that have come through. Okay, this one I think is missing a verb, so I'm going to just do my best here. Does Wallarm maybe have a real-time scanner like RASP? I don't know if it's the correct verb.
RASP is good. RASP is good. Yeah. So we basically have like two products. One is the to protect the workloads and their APIs and apps and that are in production. So and for that we are using agents that can be deployed as a module for the load balancer, or it can be deployed as a RASP middleware RASP module, or it can be just a reverse proxy Docker or Kubernetes ingress. So we have this component basically to analyze the traffic, what is going on with the application, and mitigating all kind of OWASP or API abuse or credential stuffing, this kind of things. We have a module that is trying to identify all the assets of the company. So if you have different kind of domains, subdomains, IP addresses, we will try to identify what's your environment looks like for the attackers, what are the low-hanging fruits for the attackers. We scan all those assets for different kind of CVEs and misconfiguration issues. And the third thing is that we have the module that we call active threat verification. We can gather hacker intelligence, basically the payloads and the text types from the traffic of the customer, and can kind of replay them in a safe fashion against the copy of the application and see if any of those attacks are targeting our actual vulnerabilities. And for the FAST product, it's all about the dynamic scanning and fuzzing. So how to create the security coverage based on your existing tests and to identify issues like SQL injections, XXC, SSRF in APIs and apps.
Excellent. Okay. All right, we're running up against about 5 minutes to the top of the hour, so I think we can get to one or two more questions here. How can I install Wallarm on Jenkins? Do you have any plugins to integrate?
Yeah, so one of the options is to use our API. You can call the API methods like, hey, record the baseline, another API method, start the scanning, and another API method, please return the results of the scan. The second option is Jenkins plugin. So you basically can use the plugin to simplify the things. And these are two options. In most cases, we see companies prefer to use the API because it provides them more flexibility. They can use some very complex scenarios that allow them to be more flexible. But the API, the Jenkins plugin is there as well.
Okay, excellent. Okay, last question here. How does licensing work for Wallarm? Do you go by number of integrations, or how does that work?
We basically charge by the number of the apps. So for the production product, web product, it charged by the number of the requests that are analyzed. For the FAST, for the testing product, we charge by the number of the apps. And I know the app term is a kind of vague, but we usually try to identify what are the different parts, like what are the solid parts of the apps. For instance, if it's a bank, there would be one app as the online banking, another app for kind of mobile API, another app is the website, and so forth. So, but basically speaking, we're charging by the number of the applications.
All right, great. Well, we're a couple minutes to the top of the hour, so unfortunately we're going to have to close out the question and answer period now, but I do want to thank everybody who did submit questions. And if we did not get to your question, please know that the folks over at Wallarm will be getting a copy of all of the questions, so I'm sure somebody from the organization will be more than happy to follow up with you offline. I also want to remind the audience that today's event has been recorded. So if you missed any or all of the presentation, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. And while you're there, please take a look at some of the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Stepan, thanks for giving such a great presentation today. Lots of great questions, so I could tell that the audience was really into it. So very, very good presentation.
Thanks for having me. Thanks, guys, for all those questions. Feel free to reach out to me at si@wallarm.com. I'm open to any other follow-up questions.
Excellent, excellent. All right, great. Well, do want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Have a great day.